So we built this section over in JavaScript. I'll stop there for a second. So what we did is this red area of Webkit, we replaced it with JavaScript. So we calculate the rendered CSS3D matrix transform and send it directly to the GPU, thus bypassing the inefficient parts of Webkit and doing it ourselves in JavaScript. Now, most people say, JavaScript isn't as fast as C, that's retarded. But it's, again, right tool for the right job. And in this scenario, this architectural scenario, when we test this, we are 14 times faster than the C code in Chrome. What's more important than that is frame rates are important, because frame rates go like this if you use the primitives in CSS3. If you use famous, they're like this. Constant. So they're predictable, constant frame rates are the things that you're looking for. I'm going to skip that for now. So again, we ignore CSS3 transition primitives. We compute the transforms in our render engine ourselves, and we inject that answer, if you will, that result into a parent div that sits above whatever the object is that we're trying to control in 3D space. And we send that 3D transform directly to the GPU. Thus, everything in Famous is GPU accelerated. Everything is in full 3D by default. And the inspiration for this came from the gaming industry. We looked at how the Unreal 4 engine managed performance and the Unity 3D engine managed performance. And we basically built a shitty game engine. That's basically, at the end of the day, if you said, what is Famous? It's a crappy game engine written in JavaScript. And the difference between us and the Unreal 4 game engine is, the Unreal 4 game engine can manage millions of surfaces and do beautiful 3D landscapes. We can only manage 500 surfaces at 60 frames per second. But that's enough to do any app on Earth, easily. Facebook is about 20 surfaces tops. How about a demo? And I forgot to say, then on top of this, to control all of the surfaces that we built in our surface rendering engine, we built a physics engine. So I'm going to give you a little bit of a sneak preview at our physics engine that we're going to be releasing in April 1st, oddly enough. We've all seen a scroll view, so here's a simple scroll view. And we talked about the abstraction violation that CSS3 causes between designers and engineers. So we wanted to appropriately put that abstraction back in place so that designers could design without affecting performance in any way possible. So what we did is we attached to our surface rendering engine, which is the thing that solves performance, we attached a physics rendering engine to it, just like a gaming engine would. So everything in Famous is controlled by physics, not by transforms. And so in this scroll view, these panels have weight and mass, and the black area behind it has friction that we can manage. And so an example where a designer is looking at this and says, you know, this doesn't quite feel right. I want it to bounce at the end of this. Has anybody ever coded a bounce in a scroll view? There's several ways of doing it. There's the Bezier curve method that only works on Chrome, doesn't work on Safari. You can then use keyframe animations to do it in a two-step keyframe, but those aren't interruptible. So if the user ever grabs it in the middle, you're lost. Then you can custom code it in JavaScript, but then you have the problem where every time the designer wants to change the bounce, the engineer's got to rechange his code, and that's when you get into fisticuffs. Or there's the Famous way. So this is controlled by physics. So if I want to just reduce the damp at the end of the edge, I get a nice, juicy bounce. In fact, I can reduce this all the way to 0 and create a clock. And the idea here is that in a physics engine, you have kinematic actors that you can surface and make available to the designer. So imagine a world in the future where these kinematic actors actually live and breathe inside of the inspector. And so if you ever opened up the inspector and you see all of the divs of the HTML on the left, and normally you see CSS on the right, imagine there's a new famous panel where you see the kinematic actors attached to every single div element in the HTML. That's the future that we see. What's more, you can actually change this live, and I can actually say you wanted to have boing, which is another request. So what we're able to do now in the future is that when you create a shape or an object in HTML, you can now say this object is made of plastic, this object is made of metal, this object is made of hard rubber, this object is made of foam. And you can now model things and design things in ways that make sense to designers. But this designer, for example, can never affect performance. Once you start surfacing this type of design methodologies, you start thinking of new design metaphors that you never thought about before. So for example, this little presentation that I have up here appears to be paginated. And we've offset it on purpose here so you can kind of see what we're going to be talking about. But in the middle here, that's not paginated. What we did is we actually modeled a magnetic strip in that gray area. And then we have magnetic strips at each end of the iPad. And the idea is, how many times have you been on a paginated presentation and you know you want to get to the end, where there's something of interest at the end, and you have to go to page, 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 page. Doesn't it make more design sense to make it more like a roulette wheel, that if you throw it with enough force, it breaks that magnetic barrier? So here I can go, see if I can do it, go all the way to the end, and you starting to invent new ideas that you never thought about before. And once you get into this paradigm where you're abstracting this correctly, and you have a 3D model that's 3D correctly, you have a surface engine that always is managing performance for you, and you have a kinematics physics engine that's always managing physics for you, doing 3D inside of this space, in this case, I'm looking at about 15 lines of code to do anything I want. Now let's pull this all together into my favorite demo, which apparently I need to refresh. So this demo doesn't look sexy, but it's actually my favorite of all time. This is an infinite scroll view with momentum, the hailed example that Facebook could not conquer. And what we've done is this will every once in a while animate on its own just to make it more difficult for us. But I'm going to take it back to its original state here. So here I am, and I can go infinitely. Now, if we combine the physics engine with the surface rendering engine, we can start doing things that really seem out of bounds here. So for example, what if I am throwing this object, it's inserting new objects into the scroll view, and I do what's called a cross-transform 3D matrix, which means I'm not only interrupting the animation in mid-flow, I'm actually transforming it in 3D space into a different direction while it's updating DOM. So what I mean by that is simply this. So I'm throwing this, and I grab it, and I do this. That seems to be the trifecta, but it isn't. Here's the beauty. The code that generates this is less than 1/2 of 1 kilobyte. So the entire surface rendering engine and physics rendering engine up here right now is less than 1/2 of 1 kilobyte. So this is all just a simple factor of using the right tool for the right job. And so what we decided is we fell in love with our own framework that was trying to help us build this darn Pinterest app. And we went to our investors and were saying, you know, we don't really want to build that Pinterest thing anymore. We'd rather build our framework. And so, showed you all those demos. So we realized that the engine that we were working on was more important to us as engineers than the damn product we were trying to build. And so Famous is now, we are building a full-fledged HTML5 framework that's going to compete head-to-head with Xcode. And we are literally going down the features that are included in Xcode and going one for one and making sure that we have something much better than whatever Xcode has at each stage of that. And we're going to be announcing 4 engines that we've built, actually. I've demoed 2 here to you today. One was the surface rendering engine, the other was a physics rendering engine. I mentioned briefly our gesture engine, which is going to handle all different types of gesture inputs. And then lastly, we're going to be announcing, I believe in April, our multi-view screen Cloud OS engine. And what that allows us to do is to flick any screen or any part of a screen from and to any operating system, including any television set. So you'll be able to flick from any mobile device right onto any TV, regardless of the operating systems that exist within those systems. And again, this is the promise of HTML, and we knew that if we solved performance first, that was the proper way to do it. So we built our engine first, and now we're building the rest of the car around that engine, if you will. That's the end of my presentation. I hope I helped, through the journey that we went through. Happy to answer any questions that you have.